students, so here we are with the question 5th of the exercise 3.7 for the chapter pair of linear equations in two variables. So the question 5th is, in a triangle ABC, angle C is equal to 3 times the angle B, which in turn is equal to 2 times the sum of the angle A and angle B. Find the three angles. Before doing this question, let us make some assumptions. So what are the assumptions? Let angle A be equal to the variable x, that is, x variable denotes angle A. Angle B be equal to the variable y, and angle C be equal to the variable z. So if we put these variable assumptions into the condition being provided in the question, so what we will be getting is C is equals to 3y is equals to 2 into x plus y. Okay, so this is the condition being provided in the question. And also we know from the previous year that we have studied in the previous classes, right? The sum of the angles of the triangle is always equal to, yes, 180 degree. So what we will be writing is x plus y plus z is equals to 180 degree. Because the sum of the angles of the triangle, which is being denoted here by the variable x, y and z respectively, will always be equal to 180 degree. But if we see this equation, or I can say linear equation, it involves three variables. But as far as we have done many questions earlier, we have always encountered the equations with only two variables. There was none of the equation which includes three variables in it. So means in order to convert this equation with three variables into the equation with two variables, we need to make some substitution. That substitution will be such that it eliminates one of the variable among the variables x, y and z. So how this elimination of one of the variable will be done is, if we see this condition being provided in the question, we can substitute in place of z 3y, which is perfectly fine because it's been given in the question itself that z is equal to 3y. Means it is perfectly okay to make the substitution in place of z 3y. That won't make any difference in the question being asked to us to solve. So making the substitution, I'll be getting x plus y plus 3y, that is z is equal to 3y, will be equal to 180 degree or 180. I can write it there because it's clear that it's been involved angle. So the integral value will also be degrees. Okay. And adding them, or I can say by solving it, I'll be getting x plus 4y is equal to 180. But from this step, I know in order to get the value for the variable x and y, I need some another equation too, which involves these variables. That is, if I need to solve the equation for two variables, then I need at least two equations, two linear equations I can say. But here I have only one equation. Then from where to get equation second so as to get the value for the variables x and y? If I again see this condition being provided in the question, the two equation can be obtained from here, which is being in question itself. Let me write it more clearly, okay? So what has been given is z is equals to 3y, which is equals to 2 into x plus y, right? So the second equation can be formed from this, as it's given in the question itself that 3y is equal to 2 into x plus y, means I can use this equation to get the another equation so that I can have the value for the two variables. So writing this, or I can say solving this, it will be 3y is equal to 2x plus 2y, or I can write it as 2x minus y is equals to 0. So writing this equation over here, it will be the first equation, and the second equation will be 2x minus y is equals to 0. This will be the second equation. Right. And as I know, I can solve two linear equations by three algebraic method. I'm here solving it by using the elimination method. And what does the elimination method say is that I need to ensure that any of the one variable has its numerical coefficient same in both the equations. And say if I focus over the variable y here, and as I say in the first equation its value is 4, but in the second it's 1 numerical coefficient value, I can say, right? So in order to make it 4, what I'll be doing, I'll be multiplying both the sides with the number 4 so that it won't change the significance of this equation, but I get the coefficient same as what I want. That is 4. The two equations from here will be x plus 4y is equals to 180, and the second equation is 8x minus 4y is equal to 0. Now adding this both the equations, what I'll be getting is 9x is equals to 180, or from here x comes out to be equal to 20 degrees, right? As x is the angle, so it's been expressed in degrees. Now in order to get the value for the variable y, I need to substitute this value of the x in any of the equation, either first or second, the choices being yours. Let I am be substituting this value of the x in second equation. So it will be 2 into 20 minus y is equal to 0, or y comes out to be equal to 40 degrees. Now in order to get the value for the third variable, that is z, what I'll be doing, I'll be substituting the value of the y over here. That is, as I know z is equal to 3y, or I can also take the relation as z is equal to 2 into x plus y. I can use any of the relation and substitute the value of y and x respectively in order to get the value for the variable z. So let's be substituting, that is I'm using the relation z is equal to 3y. So here substituting the value of the y, that is 40, I'll be getting the value for the z be 120 degrees. So I have got the value for the variables, or I can say the value for all the three angles of the triangle A, B and C. For the angle A, its value is 20 degree. For B, its value is 40 degree, and for the angle C, its value is 120 degree. And I can verify it by adding all the three angles. Its sum will definitely be equal to 180 degree, which was pre-assumed, right? So this was about the question 5th, and just remember that there is no restriction that you can use only z is equal to 3y in this case in order to reduce this equation into two variables. You can also use the relation z is equal to 2x plus y. This will also be perfectly fine, and the answer which you will get will be the same as I have obtained here in this case. So there is no restriction, but just keep in mind that you need to form the relation from these very condition only. Don't use any other condition to get the substitution or to get elimination of any one of the variable in the equation of three variables, that is x plus y plus z is equals to 180 degrees. So this was about question 5th of the exercise 3.7. I hope this question is clear to all of you.